Imagine you're sitting in front of me and you ask one question: how do I land a high-paying job as a computer science student? Most people would immediately start talking about programming languages, solving leetcode, or maybe top universities. And to be honest, those things matter. But they're only a part of the answer. So the first thing that you need to understand is that companies don't hire students because they know the most. They hire people because they have problems that need to be solved. Every time a company opens a position, it's making an investment. It's spending money today because it believes the person it hires will create even more value tomorrow. That's how every business works. Once you understand that, your entire approach to college starts changing. Instead of asking, which programming language should I learn next? You start asking, how do I become someone a company would confidently invest in? That's a completely different question, and it leads to completely different decisions. I think this is where many students accidentally go in the wrong direction. From the day we start school, we're taught that success comes from collecting good grades. Study hard, pass the exam, move to the next subject, and repeat. There's nothing wrong with that system because that's exactly what schools are designed to do. The problem is that many students carry the same mindset into college without realizing that the rules have changed. A company doesn't hire you because you scored well in database management systems or operating systems. Those subjects are important because they build your foundation, but the company is trying to answer a different question. If we hire this person, will they help us solve real problems? Notice how different that question is. Nobody is asking whether you remember every definition from your textbooks. They're asking whether you can think. Think about the best programmer you've ever met. Was it the person who memorized the most definitions? Probably not. It was probably someone who stayed calm when everyone else got stuck. Someone who enjoyed breaking difficult problems into smaller ones until they finally found a solution. A framework that's popular today might become irrelevant a few years from now. A language that's in demand today could become less important later. Nobody can predict exactly what software engineering will look like 10 years from now. Companies know that. That's why they aren't looking for someone who's only useful today. They're looking for someone who will still be useful when the technology changes. And that's where I think most students misunderstand learning. Many students treat programming like history. They try to memorize everything. Then they panic when they forget something. But experienced developers forget syntax all the time. The difference is that they understand the ideas behind it. If you understand how software works, searching for syntax takes seconds. If you only know syntax, rebuilding your understanding takes months. That's why I always tell students that understanding compounds while memorization expires. One gives you something you can build on for years. The other disappears surprisingly quickly if you never use it. The same thing happens when students ask me which programming language they should learn first. I understand why they ask. Nobody wants to waste time, and nobody wants to make the wrong decision. But sometimes I think that question hides a deeper fear. It's the fear of starting. Because if someone else tells you exactly what to learn, you never have to take responsibility for the decision yourself. The truth is, there isn't a perfect roadmap. There never has been. I've seen students build amazing careers starting with Java, and I've seen others do the same with Python. The language wasn't what made the difference. Their consistency did. They kept learning long after the excitement disappeared, and that's the part people rarely talk about. Everyone loves the beginning. Buying a new course feels exciting. Planning a study schedule feels productive. Setting ambitious goals makes you feel like you're already moving forward. The difficult part comes a few weeks later, when the excitement disappears and all that's left is the work. That's where careers are built. Not on the days you're motivated, but on the ordinary days when motivation is nowhere to be found, and you decide to show up anyway. One habit completely changed the way I think about learning programming. Instead of asking myself, what should I study today? I started asking, what can I build today? That one question forces you to think differently. When your goal is to study, finishing a chapter feels like progress. When your goal is to build, you quickly realize how many things you don't understand. At first, that's uncomfortable. You'll spend hours trying to solve problems that looked easy inside a tutorial. You'll wonder why everything suddenly feels so much harder. The answer is simple. You're thinking for yourself instead of following someone else's thinking. Tutorials are useful, courses are useful, books are useful, but they all have one thing in common. Someone else has already made the difficult decisions for you. They've decided what you'll build, what order you'll learn things in, and what problems you'll face. Real software doesn't work like that. Real software starts with uncertainty. You open a blank editor with nothing but an idea, and from that point onward, every decision belongs to you. That's where your education begins. I've met students who watched hundreds of hours of programming content but froze the moment they tried to start a project on their own. That wasn't because they weren't intelligent. It was because they'd spent months watching other people solve problems instead of solving their own. There's a huge difference between recognizing a solution and discovering one. The second is much harder, but it's also the skill companies are actually paying for. Eventually, you'll reach a point where your code stops working, and this time it won't be because of a small typo. It'll be because you genuinely don't understand what's happening. Those moments are frustrating, but they're also incredibly important. Every experienced engineer has been there. They've stared at a screen wondering why nothing makes sense. They've questioned themselves more than once. What separates them from everyone else isn't talent. It's that they stayed with the problem a little longer. They kept reading, kept testing, and kept thinking until something finally clicked. Every difficult problem leaves you with something far more valuable than a working program. It leaves you with confidence. Not the kind that comes from believing you know everything, but the kind that comes from believing that you'll eventually figure it out.